Hello, Gregoire.
Hi.
Hi, how are you?
Yep, good, thank you. How are you?
I'm Grant. Are you ready to get started?
Yep.
Um, so did we say we were continuing the revision stuff?
Yeah.
Okay. Yeah. And I just need to do this. Hopefully this doesn't crash. 'Cause it's been crashing. Yeah, good. Okay. How do we do this?
Okay. Replace constant should of y equals 2. Can we multiply the top one by 2, so that gets 4kx minus 2y equals 8? And then the bottom one will be the same, so 4kx plus 3y equals minus 2. And then we subtract them from one another, so it becomes minus 5y equals 10. And then that simplifies to y equals minus 2.
And B.
Find the expression for x in terms of course of y. So that would be in the form x equals something k. So we could try getting rid of the y.
How would you do that?
Multiply the top one by 3 and then add them together.
We could. How do you usually find the second answer for simultaneous equations?
You can substitute in the value of y.
Yeah, and that will still work for this one.
Yeah. So you put in minus 2 for y, so 2kx minus 2 equals 4, and 2kx plus 3 times minus 2 equals minus 2. So that becomes 2kx plus 2 equals 4, and 4kx minus 6 equals minus 2.
You only need to do it with one equation.
Oh, okay.
You'll get the same answer.
Oh, that's true. So I'll do the first one. Then from here we make it 2kx equals 2. And then kx equals 2 over 2, which is 1. So then x equals k? Or 1 over k?
1 over k, yeah. That's it. So they wanted x in terms of k, and so that means k must be in your answer. That's fine. Okay, how do we solve this?
We can make the top one into terms of x. So x equals 3 minus 2y.
Yep.
And then we substitute that into x squared.
What do you get?
So 3 squared minus 2y squared minus 4y squared equals minus 33.
Say that again, sorry?
So bracket 3 minus 2y close bracket squared,
Yeah.
minus 4y squared equals minus 33.
Yeah.
Okay. And then you expand the bracket, so that becomes it becomes 9 minus 6y minus 6y and plus 4y squared. Is the last part correct?
Yep.
Okay. So plus 4y squared minus 4y squared equals minus 33. So you can simplify that to 9 minus 12y equals minus 33. And then you can get minus 12y equals minus 42, then 12y equals 42. And then y equals 42 over 12.
Yeah.
Yeah, so that's a fraction. 3 or 3.5, yeah.
And is that form
So-
x?
So that's for y, and then you can just substitute it in to the top equation. So x plus 7 equals 3, then x equals minus 4.
X equals minus 4. That's it. Well done. I think you're okay there. I think you'll be fine for these. How would you solve this equation?
So you rearrange the top one to get y equals to minus x, and then you substitute that into all the places where there's y.
And for part B, you have to solve this quadratic. How would you solve that?
You should use the quadratic formula.
There's a much easier way.
Just do the trick where you look into what multiplies and what adds together.
Calculator, man.
Oh.
Yeah, just put it in
Fair
your
enough.
calculator. Yeah,
Okay.
and then you just go from there. So I think you're okay for these. Okay, how do we do part A?
Okay, so 3 to the x equals 9 to the y minus 1. So we could get 3 to the x equals 3 to the 2 brackets y minus 1. 3 to the x equals 3 to the 2y minus 2.
Yeah.
So then x equals 2y minus 2. And you want to bring it over to the other side.
No. So 3 to the x is equal to 3 to the 2y minus 2.
I thought, it doesn't actually make a difference.
Therefore, x is equal to 2y minus 2. Yeah, you've shown that. And then the second part is simultaneous. Okay, let's try this.
So the two lines intersect.
Yeah, at a single point.
The value of k. So we can make them equal to each other because they both equal the same thing.
Yep.
So kx squared minus xy plus k plus 1x equals minus k over 2x plus y.
What's next?
And from here, you would want to get k by itself, but you can't. All the letters are slightly confusing.
So I think what I'd do is fully expand any brackets and then fully simplify. So like x squared with x squared and all that.
Okay. So there's a bracket that we can see straight away, so that would be kx plus x.
Yeah. Okay, x plus x. Let's bring everything over to the left side.
So we can have kx squared minus.
Hang on, no. This isn't good.
Oh.
We still have a mixture of x and y.
Yeah.
So let's actually just pretend there's no k and just try to solve it.
Okay. So we can rearrange the bottom one to make it equal to y.
Yeah, that's a good idea.
So y equals 1 plus k over 2.
Yeah. K over 2x?
Yep. And then you substitute that in to the equation on top. So k bracket 1 plus k over 2x squared minus x 1 plus k over 2x and so on.
Yeah. And then same thing.
One. And then we open the brackets, we multiply out the brackets. So kx squared minus x plus k over 2x squared.
Mm-hmm. And I'm going to say minus 1 equals 0.
Okay.
What next?
From here, you want to get as few, so you want to clear it up. So the x's cancel out, just the x by themselves. The k x squares, can they affect each other?
Yeah.
What's kx squared minus k over 2x squared?
Factorize out the x squared.
Oh, so x squared k minus k over 2?
Yeah, and so it's basically going to be k minus k over 2 x squared.
Yeah.
What is k minus k over 2?
K minus k over 2 is just I'm not sure actually.
K over 2 is the same as a half k.
Oh, it says k minus half k. So then it's half k?
Yeah, so it's k over 2. And so it is k over 2 x squared.
Yeah.
What about the x's?
They remove themselves. So it's plus kx
Yeah.
minus 1.
And that's equal
0.
to 0. Okay, we have to find the value of k. How do we do that?
If we solve a quadratic, that will only give us x. won't it?
Um, yes. This is where they gave us the thing.
Intersect at a single point.
So that piece of knowledge allows us to do this.
I'm not too sure how to apply it.
If they intersect at a single point,
They're grey.
it means that you only get one solution.
Right.
And it's a quadratic. When do you only get one solution with a quadratic?
When they touch the line when the gradient is 0 at the intercept.
Yeah. So let's say the quadratic formula, when you end up with just one answer, one solution, instead of plus or minus.
0.
What is 0?
X is 0.
The discriminant is 0. So
oh yeah.
The square root bit, when that is 0, you get basically plus or minus 0, which is the same thing. And so you only get one answer. What is the discriminant?
The discriminant is minus b squared minus 4ac.
Yeah.
And to make that equal to 0. So we substitute in the values that we've got. So that's k squared minus 4k over 2.
No. A is the first. Oh, sorry, you're right. Sorry, k squared, yeah. Sorry, minus 4k over 2.
Yeah, k over 2 minus 1 for 0.
Yeah.
And then from here, we rearrange it to get 0, so to get k. So we can open the brackets, multiply the brackets. So that's k squared minus 4k over 2 minus 4 equals 0.
And so simplify.
So just 2k minus 4 equals 0.
Yeah. And will it be minus 2k or plus 2k?
Minus 2k.
Minus 4 times minus 1.
Oh, plus 4.
Yep. So plus 2k equals 0.
Is it still not minus 2k?
Minus 4 times k over 2 times minus 1. Or if you
yeah.
If you looked at it as 4 times k over 2 times minus 1, then it would be minus 2k. And so you end up with the same thing.
What did I do? I did 4 times k over 2 and then 4 times minus 1.
That would be if they had a plus in between them. It's just all 3 times each other. So first times second times third.
Okay. k squared plus 2k equals 0. We could... No, we can't divide everything by 2 or square root them. Or could we?
How else could you solve it?
Quadratic equation.
Yep.
Or complete with square.
Yes. What way would I solve it?
Using a calculator.
Bingo.
Just using plus 0.
Bingo.
So I get 0 and minus 2.
So which is it?
So it's non-zero constant, so it would be minus 2.
That's it. B.
Give the coordinates of a point of intersection of the line and the curve. Okay, so we have k, so we can implement that into one of the equations.
Mm-hmm.
So we can do it to the bottom one.
Okay.
So it would be 2 over 2x plus y equals 1.
Mm-hmm.
And from there we can get, we could rearrange it and then make it into a simultaneous equation.
Yeah. What is 2 over 2?
1, so just x.
So x plus y equals 1.
Mm-hmm.
Okay.
So then we can make it equal, so we could do x equals 1 minus y.
Yep.
And then we can substitute in x, so minus 2 times 1 minus y
Mm-hmm.
equals 1 minus y times minus 2.
Hang on. What was it at the start again? Minus 2.
1 minus y squared.
Yeah. Yes, squared. Yeah.
Yeah. So you have plus 1 minus y times minus 2. So plus 2, 1 minus y.
Why is that?
Because minus times a minus is a plus.
So are we looking at the minus xy part?
Yeah.
What is x?
X is 1 minus y. Yeah. And then minus 2.
K is minus 2.
Oh, it's y. Oh, so just y.
Yeah.
Plus minus 2 plus 1 times 1 minus y equals 1. Or minus 1 equals 0.
Yeah.
That's a lot of stuff going on. For this, do we multiply out the brackets and then find what's left?
Yeah. Fully expand everything. Fully simplify everything.
Okay. So 1 minus y squared equals 1 minus y plus y squared. And then that's all minus 2 minus 2 plus 2y plus 2y minus 2y squared.
What is minus y squared?
Minus y squared. Plus y squared.
And so when you expand it by minus 2?
Minus 2y squared.
Yeah, I think you said plus 2y squared.
So yeah, the next one is minus y squared.
What's minus?
Oh, it's a minus and minus.
Yeah.
So plus y squared. And then this one So that's minus 2 minus 2 or plus 2i.
Hold on. What is minus 2 plus 1?
Minus 2 plus 1.
Mm-hmm.
Oh, minus 1.
Yeah, so you can simplify that into just one thing.
Oh, okay. So minus 1. So it would just be minus 1, yeah, plus y. Minus 1 equals 0.
Wow. Alright,
It's
simplify.
a long one. So you get minus y squared.
Mm-hmm.
Then 4y, so plus 4y.
Yeah.
Minus 3 equals 0.
Close.
Oh, there's another minus 1, so minus 4.
Yeah.
And then so I get 2, and that's twice.
Oh yeah, because they said it does have a intersects at a single point.
Mm-hmm.
So y equals 2. Is that full marks?
No, we need to find x, so we can substitute in minus 2 to the bottom equation.
Yeah.
Just 2, normal 2.
And in fact, we here made x the subject.
Yeah, so x equals 1 minus 2, so x equals minus 1.
Minus 1. Yes, so let's go back. So the first one, although it looks different, so the way we solved this second one is the totally normal way. We made x the subject, we subbed that in for all the x's, and then we just solved it. The way you do part A is exactly the same, even though it's got k in it. You make x or y the subject, you sub it in, you solve it as much as you can, so you get it to the point where it's a quadratic, and now you're like, okay, I can't solve it.
Mm-hmm.
But they tell you it intersects at a single point, and so you know that b squared minus 4ac must be equal to 0, and so you sub into that and solve that to get k.
Yeah.
And so it's just like solving a normal quadratic, except with that little thing. Any questions about any point there?
No.
It's just long and brutal, but we've done it. Okay. How about this?
Okay, so the boards. Determine what the model predicts the ball will hit the ceiling. So for this one, we make them equal to one another.
Yep.
And once they're equal to one another, we turn it into a quadratic.
Mm-hmm.
And if it comes with a set of outcomes, that means it hits. And if it doesn't, they don't.
Yes. Determine whether the model produces. Okay, try that one. I'll just be a sec.
Okay.
How do you get on there?
I'm just simplifying it. So
Okay.
yeah, I've equated it to 0 and just choose that one. Minus So I've come up with minus 3 over 10x squared plus 27 over 10x minus 6 equals 0.
All right. So put it in, see what you get.
Mm. And I get 5 and 4 as my answers.
Yep.
Meaning it does hit.
And where does it hit?
It hits at 2 points. Well, it will be the first point because the other point is when it redescends, supposedly.
And so which point is that?
So x. It would be the first x point where x is 4, and then you substitute it into one of the equations.
Yeah, I would say x equals 4. That's fine.
Yeah.
And yeah, you could get the height by subbing it into, let's say, the second equation because that's easier.
Mm-hmm.
But yeah, I'm just checking. So yes, hits at. Does it actually say? So the height is m meters to the distance it was thrown. At distance of 4, let's say.
Okay.
4, but yeah, just making sure. So they kind of didn't say exactly if, it's just determine if it hits it or not. Like, obviously, if you just wrote down yes, you'd get 0 marks. So I'm just kind of wondering what they're looking for. And I think if you said it hits, I think if you just said x equals 4 or x equals 5, therefore, yes, it hits it, I think that would be enough.
Okay. Okay.
Yeah, something like that. And I mean, especially if you said, yeah, it's going to hit at a 4, then it's like, well, then they definitely know it.
Yeah.
This.
Answers in set notation. Set notation is.
Oh, I forgot about set notation. Okay. So.
Oh, set notation is greater than. Stuff like that.
So that's your set notation there. X such that x is greater than minus 5 in curly brackets.
Uh-huh.
Oh, that's weird. Alright.
Okay.
Let's try it.
This would be. Oh, so it's basically keeping it the same, just using the set notation instead of the equal sign. Okay. So here it's basically the same as a simultaneous equation. So we can, not even that, we can just bring over x to the left and to the normal numbers to the right. So we get 2x is greater than 21.
Mm-hmm.
And then the second one is quadratic that I would do now.
Hold the phone. 2x is greater than 21.
Oh, so then x equals 10.5.
That's
Oh,
great.
it is Greater than typical.
What is that in set notation?
Is that also x such that x is greater than simplified?
Yeah.
In curly brackets.
Yeah. So curly brackets and x such that. Okay, B.
B is. So then you just do a quadratic equation with it.
Yep.
5 minus 5 and minus 14, and you get 7 and minus 2. So x is greater than 7, or x is greater than minus 2.
You're using your graphical one, is it?
Yep.
On this one, they have one for inequalities. Can you solve an inequality?
Equality. It's probably here. Simultaneous polynomial than 0. More than 0.
Mm-hmm.
I don't know how to run it exactly.
Just making me. Okay, let's see. CG 50.
So you go to the graph one, which is number 5.
Oh, why did they do that to me? I think it's like view, calc, screen, small. Number 5 is graph.
Mm-hmm. And then if you click tool or delete, so F2.
Oh yeah, okay.
Yeah.
Tool 1, 2, 3, 4.
Tool. Okay, it isn't tool. It's the other one.
Type, maybe.
Type. Yeah. And then go right twice.
So Y was it greater than?
And the next one is X as well, if you click it again.
Okay. So we want X is greater than.
Yeah.
Okay. And so we're doing X squared, is it?
So X squared. Ooh. Minus 5.
5x minus 14.
Minus 14. For me, when I write it down, it becomes x is greater than y squared minus 5y minus 14. Does it make a difference?
We're about to find out. 14. To press execute.
Yeah. And then draw.
Draw. I have to press back up or something. Draw. See, now I'm doing 0. And y is less than. No. This isn't it at all. Alright.
No.
Well, it's not bad, but it's not quite. It's not quite like the other one, just inequality type.
Can we not still just do the quadratic formula? And assume?
No. So here's on my calculator. We had x. We have 1, minus 5, and minus 14. And if I press equals, you can see that x is less than minus 2 and x is greater than 7.
Okay. I mean, it does come up with those values, obviously.
And
but
so,
you
yes.
get x1 and x2. I guess you can just assume for x.
And is it? How do you know that it's less than minus 2 and not greater than minus 2?
You don't know. It doesn't say.
Okay. Maybe you can kind of just use the graph. So if you have your graph and it's like that or something, you're just asked when is the graph greater than 0. Well, it's greater than 0 when like x is less than -2. And it's also greater than 0 when x is bigger than 7.
Got it.
So that's how it works. It's just a shame. The simpler calculator, so you can see there, I just put it in, and it has like a quadratic inequality solver.
I'm sure there must be a way to do it in this one.
Yeah, it's just going to take going through the whole thing. Is there nothing? So this is all the graph. Drawing a graph. To change the type of function is probably graph. This looks like a solver. No, inequality graph again.
On the graph, it does tell you the intercept points.
Yeah, and I think just draw the graph and then just see where is the graph greater than 0. I think that's the easiest way to do it. And you can just see like the graph is like the y coordinate is more than 0 when x is greater than 7 and when x is less than -2. I think that's the only way to do it, really.
Yeah.
Hang on, let's take a quick look at this one. No, quick look at this one. Inequality symbols. So I have to contest if it's true or false. Graphing inequalities is not what we want. Nah, I don't know how to do it. Anyway, was this set notation? In set notation is written as that. X is greater than -2 or x is that. Okay. So x is less than -2. Can you hear me? Hello? Hi, can you hear me? Hello? I can't hear you. Can you hear me? I'll try. Can't hear you at all. I can now hear you just about. Can you hear me okay? Yeah, I don't know what's happened. Okay, let's try this one, and I'll just make sure that my daughter isn't like doing something crazy on the internet in the other room. Just a sec. So hopefully it gets better. Any idea about this one?
I think it's just but I'm getting x squared minus 5x plus 4 is less than 2x minus 16.
2x minus
minus 16.
2 times -4.
I think that's a 4. I already did. Yeah, it's 8.
That's it.
So from here we can side over to the left. So
Mm-hmm.
that becomes x squared minus 7x. And then minus. Oh, yeah, yeah.
So you're doing plus.
So minus mx plus 12 is less than 0. And then we can use the quadratic equation on a graph for me at least.
So try that on your calculator.
Yeah. So for the quadratic equation, I get 4 and 3, so so 4 and 3.
And
And that's for the graph. Time is y is greater than y is greater than x squared minus 7x plus 12. Accurate. It gets to 3 or 4 as well. And x is less than 3, and x is greater than 4. No, x is less than 4, x is greater than 3.
yes,
Yeah,
x is greater than
it's
3.
the shade theory.
Yeah, and so to put the two of them together, it would be that. So the previous one, you can't put them together. X is greater than 4, is it? Oh, hang on, no, I need to change my thing. Hang on. Inequality 2 less than is 2, and that's yeah. Great. Any questions there? Okay, x is between 3 and 4. Let's just see this one. I think you're okay there. Same thing. And then, okay, how about this one?
I'm not saying, okay, find set values of x will be the middle of the line equation. So we want to find the intercept points between the first line and the second line. So we made them into simultaneous equations.
Mm-hmm.
2x squared plus 3x minus 15 equals 8 plus 2x.
And technically it's not equal to, so let's go straight to the, what would it be? What sign would it be?
Y is not equal. It's still y. It's y not a constant in this case.
Like, would it be less than? Would it be greater than?
So when x plus 2x is greater than, which you want to find the top one beneath the row.
So because it's below the line, we want when the quadratic is less than the line.
Yeah.
And so, yeah. Okay, go on. What's this one?
So then we can bring over the ones on the right to 2x squared plus x minus 23 is less than 0.
0. Yeah, go on, try it.
And then I'll do this. X is 2 squared plus x minus 23. Draw that. I get x is, yeah, so this is the x intercept, right?
Yeah.
So x is greater than minus 3 point something.
Ah, okay.
It looks like 3.6.
Yeah, minus 3.65.
And x is less than 3.05, 3.1.
So 3.15 I have. And so, yes, so x is between those two. So let's see. Find the set of values of x, and that's what we were looking for. Yeah. Okay. Any questions there? Yeah. So you don't even have to do the equals and then solve it. You can just go straight to the less than and do it directly.
Yeah.
And that was the end of that chapter anyway. How was that for you, Gregoire?
It was good, yeah. I'm gonna try and figure out these conjugacies.
And so you could always just have two calculators, I suppose, if you can get your hands on the other calculator. And that way you can just, you just have it both ways.
Yeah. Or I'll try and find out. There must be a way of this one to do it.
Yeah, there has to be a way. And so next time, do you want to just move on to the mixed questions for the next chapters?
Yeah, maybe we could go back to kinematics because that's similar to physics, and I've got my AS for next week.
Ah, okay.
So maybe we could do that.
Okay.
Otherwise, we could continue with the same stuff.
Okay. Any questions for me in general?
No, thank you very much.
All right. Well done, Gregoire. You did great. I look forward to